Hi, this is Math 6, Unit 1, Lesson 8. And it says, let's use what we know about parallelograms to find the area of triangles today. So first of all, here is triangle M. And so the Han made a copy of triangle M and composed 3 different parallelograms using the original M and the copy as shown here. So here's the M all 3 times, and then he made a copy and spun one this way, put one on top, put one on the back side over there, all good to go. For each parallelogram, Han composed, identify a base and a corresponding height and write the measurements on the drawing. Alright, so the idea being that I take what I have here and I say, okay, let's just call a base. We'll call this a base. 1, 2, 3, 4, 5, 6. So we have a base here of 6. And we can have our height be this one right here, which is 1, 2, 3, 4. And our height equals 4. On this one here, I could call this the base, 1, 2, 3, 4, so base can equal 4. And our height could be the one that goes across to make this 90-degree angle, 1, 2, 3, 4, 5, 6. And our height equals 6. Oops, sorry, I'm off the page there. Sorry about that. So sorry. And over here, we have a base of 1, 2, 3, 4, 5, 6. So our base equals 6. And our height is 1, 2, 3, 4, because it makes a 90-degree. So height equals 4. Find the area of each parallelogram Han composed and show your reasoning. So for our first one, we would say 4 times 6 is 24. For the second one, we would say 4 times 6 is 24. And for the third one, we'd say 6 times 4 is 24. So the area for all 3 is exactly the same, which is 24 units squared. Okay, no problem there. That's just how that's going to work. Okay, looking at the second thing, more triangles. It says find the areas of at least 2 of the triangles below and show your reasoning. Okay, so we're going to take this triangle here and make a copy of it. So to make a copy, I'm going to go ahead and for this one, I can make it into a rectangle by doing it like so. It has the same height of 2 and 2 and this length there. Alright, so find the area of at least 2 of the triangles below. So when I make it as a rectangle, now I have a what? I have a height of 2 and a base of 8. So as a rectangle, I know it would be 8 times 2, which is equal to 16 units squared. But I only need half of this. So really, I can then divide this by 2 to find out what the area of the triangle is going to be, which would actually be 8. Okay? So I have really the area of this whole parallelogram, and I divide it by 2. It's half of that. Alright? Looking at C. Same idea. I can see here that I have a base of 1, 2, 3, 4, 5. There's a base of 5. And so if I extend this to go out 1, 2, 3, 4, 5, and I connect this here like so, I form a new parallelogram, right? I can have a height. I can draw any one of these as a height. I can go right there as a height, with a right angle, and my height is 1, 2, 3, 4. So a height of 4. So again, if I'm looking for what the area of the whole thing would be, it'd be the base times the height, which is 20, but I want to cut that in half because I'm only going to count half of it as a triangle, so it has an area of 10. Alright, you getting the idea so far? So the area of a triangle seems to be what? It seems to be half of the angle of the area of a parallelogram. This is half. Let's take the information, let's take a look at the next one. Okay? On this one here, a couple ways I could do it. I could actually cut this in half right there, or not half. I could draw a line like so and decompose this into 2 separate triangles. Now, I can make a copy of this triangle by noticing that it goes 3 up and 2 over, and I can go 2 over and 3 down, and here I have a copy there. This one I go over 1, 2, 3, 4, 5, so I can come over 1, 2, 3, 4, 5, and draw a line there. Alright, so I have one rectangle here and one rectangle there. The area of this rectangle would be a base 1, 2, 3, 4, 5 times a height of 3, which is 15. Over here, this one is a base of 2 times a height of 3, which is 6. And so the combined area would be actually 5, 6, 7 times 3. If I want to think of it that way, the whole thing is 7 by 3, which is 21. So 15 plus 6 combined to make 21. But again, I only want half of this, and I only want half of this. So 21 divided by 2 is actually equal to 10.5. So it's half of that. Okay? Kind of interesting thing there to consider. Alright, so let's look at this guy right here. This one here is a little bit, I don't know, I think it's a little funky looking. Okay, the way we're going to look at doing this. You'll have a few like these on your homework and upcoming lessons as well. So watch this one carefully, okay? What they're wanting you to do is to turn a triangle into, first, we're going to go triangle into trapezoid into parallelogram. That's kind of the process here. Ready? So here's what we're going to do. First thing we're going to do is we're going to go down right about here, and we're going to cut this part off right there. Okay? So now we have a trapezoid, don't we? Okay? Now let's take a look at this trapezoid shape. If I take this shape right here, this little triangle piece, this triangle piece, this is where it's helpful to have some tracing paper to see what could this do. If I take this triangle and I rotate it around, notice that when I rotate it this way and keep rotating it, I can end up right there with what? With a parallelogram, right? So I can have a parallelogram by coming out to this point right there, put a dot right there to know where it's going to go. I rotate it around and around and around. So I take this triangle and I'm rotating it there. I'm decomposing it and rearranging it. So now I have a parallelogram. Now with this parallelogram in place, I have a base of 1, 2, 3, 4, and I can have a height that goes right across here, right? And a height of 1, 2, 3. So as an area, I have 4 times 3, which is going to be 12. Now in this case, be careful because this piece is that piece right there. So in this case, I'm actually done. I'm not going to cut anything in half because I didn't like double it and make it larger. I could have done that, right? I could have extended this down and said, well, 1, 2, 3, 4. Let's extend this down and go 1, 2, 3, 4. And we could have extended this to here. And then I could have had a 4 and a 1, 3, 4, 5, 6. I could have done 4 times 6, which is 24. And then I could have divided by 2, which is back to 12. So I could have done what we did in the previous ones, no problem. But this little strategy of cutting off the tip of a triangle, rotating it down to make a parallelogram is something you might see and will see in other examples coming up. So I just want to make sure you saw it that way as well. Okay, so here we go. Let's move to 8.3. This activity is actually was optional, so your teacher may have done it or they may have skipped it, but I'm going to go through a little bit with you right now. All right, so let's take a look here. So first off, we have, you're going to get 2 copies of a parallelogram. I'm going to use parallelogram A, which looks like this, and there are about 4 different ones you could have had. It says glue or tape 1 copy of parallelogram here and find its area. So we take 1 parallelogram here. I'm going to tape that down real quick for you. So put it there, and here is our copy of parallelogram A. This is the letter A. So as a parallelogram, we have a base of 10. That's our 10. And we have a height of the whole thing here at 8. We have a height of 8, so 10 times 8 is 80 centimeters squared. Okay, no problem. We're good with that. We've done lots of those ones. Let's do the next thing. Decompose a second copy of parallelogram by cutting along the dotted lines. Take only the small triangle and the trapezoid and rearrange these 2 pieces into a different parallelogram. Okay, So we're going to cut here and cut there. So we're going to, first of all, on this one, I'm going to cut along this diagonal line right there. So now I have a medium triangle. And then I'm going to take this right here so that I have a, whoops, pick that back up, a triangle and a trapezoid. A triangle and a trapezoid. And it says take only the small triangle and trapezoid and rearrange these. So small triangle and trapezoid, rearrange them to make a parallelogram. Alright, so what we're going to do is we're going to take the tip of the triangle, like we did a second ago, and rotate that down to make a parallelogram like that. Glue or tape the newly composed parallelogram on your paper. So there's my piece of tape, and I'm going to go whoop, and there we go. Alright, looks good. Find the area of the new parallelogram. Well, this has a base of 10, a height of 4. Right, that's our 4. So we would say it's 10 times 4, which equals 40 centimeters square. So it has our base and our height, 10 times 4. Alright, what do you notice about the relationship between the area of this new parallelogram and the original? Okay, well, our original equaled 80. Our new one equals 40. So what we notice is that it is half, right? It's half the area. So the difference of half. We've cut it in half essentially, right? And if you think about it, what did we do back over here with A? We took the parallelogram and we cut it in half. That's exactly what we did, so the area should be half. How do you think the area of the large triangle compares to that of the new parallelogram? So I guess this is the large triangle here. So this triangle here, how does this area compare to the parallelogram? So here's a triangle, and here's a parallelogram. How do the areas compare? Well, if this triangle was an identical copy, because we cut it on the line, then the areas should be what? They should actually be the same. And that's because it's the same copy of that large one, right? The large one went something like this, right? Like so. And we cut it right there. And so this area here, I'll shade it in, this is a large one. This area here is the same as that triangle, which became our parallelogram a second ago as well. Okay? Now it says, number 6, glue or tape the remaining large triangle below. Use any part of the work above to help you find the area. So we can glue this right here. I'll tape it here, I should say. Alright, and what do we have? We have this is 10, and this is 8. Huh, interesting. How could that be the case? How could it be 10 and an 8 and make 80 if it really was only going to be half of it, which was 40? Let's take a look over here. Okay, so we had 10 times 8, which is 80, but that was for the whole thing and the length. Oh, well, makes sense, because what have we said so far? We take the base and we take the height, and actually the whole thing, we're only going to keep half of that, right? We end up taking half of the base and the height to get our new area. So half of the base and half of the height, 10 times 8 is 80, and half of that is 40. Okay, and that's the idea like that one right there. Alright, on the Are You Ready for More? It's just a great little question here. Can you decompose this triangle and rearrange it to form a rectangle? Okay, we saw before that we can take a part like this. We can draw a line, right? And we can rotate this down over here. Let's do that real quick together. Alright, so if I take this triangle here, 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 we rotate it around and down and down and down, so it lines up right like so. Maybe not very good there. Well, something like that, about like that. Oh, I need to find the, sorry, what I need to do is I have to do it at the midpoint. My mistake. Let's do the middle point of the whole thing. That's how it works, actually. You'll learn that in high school. So we're going to go to the midpoint. If I measured it properly, I can do it better. So that's a 3 and a bit. So let's go 1 and 3 1/2, 1 1/4. 1, 3 1/2, 1 3/4. Yeah, it's right about there. It does have to be at the midpoint. You'll learn that in Math 2 or in Geometry. Let's copy that real quick. And the reason I want that to be at the midpoint of that line segment is I want to make sure that this line can actually match up with that line right there, be the same length. So that way when I link them together like so, I end up with something like that, right? So we can draw this here. Let's see if I can see that out. Yep, it goes to there and there. Okay, so we rotate there, no problem, looking good. And now we check this part out. This is kind of fun. Now we're going to go ahead and we're going to take this where we cut it, and we're going to chop off the line right here to make a triangle like so. Now watch what this one does. Kind of fun. And again, as you get to high school math, you can actually prove why this works the way it does. And we can slide that cut off right there, and we end up with something right about here. There's my dot, and there, and there. So that one moves to there. And so in doing this, we can cut off that part, and we can actually make a nice rectangular shape. Pretty fun. And later on, you'll be able to prove why that works the way it does, recognizing chop at the midpoint, and it works out just fine. Okay, so summary. We can reason about the area of a triangle by using what we know about parallelograms. Here are 3 general ways we can do this. We can make a copy and recognize that because they have the same area, one copy of the triangle has half the area of the parallelogram. So if we know the whole parallelogram, then the area of the triangle is half of that. Okay, and we can do that by making a copy here, making a parallelogram, and again, this is half of what that is there. We can also decompose, which we did just a second ago, a triangle into smaller pieces and compose them in a parallelogram. So we could cut this at a midpoint here, and we can move it around and end up with a parallelogram, and that works out. You probably won't do this one as often, but it can be done, and it does work for what we're doing. Okay, so no problem there. Yeah, so that works out just fine. This has a base of 1, 2, 3, 4, 5, 6. Height of 1, 2, 3, 4. So I'm not sure why. I think they want you to show the connection there. Later on, we'll probably look and show that this also becomes a height. And we'll talk about that later. How then if you use the 1/2 of the base times the height idea, that at the base here is 1, 2, 3, 4, 5, 6, and the height is 1, 2, 3, 4, you end up still with 12. We'll get there later on, but just have that kind of in the back of your mind. For now, we're trying to make the connection in this lesson between a triangle and how a triangle can become and is connected to a parallelogram. So that's the idea there. All right. We can also draw a rectangle around it, and then recognize that if we remove those other parts, we can find out what the area is going to be and what's left there. And we can decompose things by, again, drawing a larger rectangle around it, taking the parts that are there, and subtracting it, and that tells us what's remaining right there as well. So you can read through the summary there. You have it in your notes as well, but different ways of approaching things. Let's pause there, let you work on your homework, and let's come back together and see how you did. All right, here we go, homework time. All right. So, to find the area of this right triangle, Diego and Jada used different strategies. Diego drew a line through the midpoints of the 2 longer sides, right there, which decomposes the triangle into a trapezoid. So, cut a line in the midpoints, made a trapezoid, and a small triangle. Then he rearranged them into a parallelogram. So he chopped it, moved it, made a parallelogram, which we've done a few times in our lesson today already. Jada made a copy of the triangle, rotated it, and then lined it up against the one side of the original triangle so to make a parallelogram. So she took this one, doubled it up, and then made a copy right there and put it side by side. Explain how Diego might use his parallelogram to find the area of the triangle. So, for Diego, he is still using the whole triangle. So keep this in mind, this is a big difference. He's using the whole triangle, isn't he? So in doing so, he has a base, which is 3, and he has a height, which is 4, so his area is simply going to be 12, the multiplication of 3 times 4, or base times the height. He's set to go with that by doing it like that, no problem. For Jada, Jada has created a larger parallelogram. She's actually added a whole section there. Now what she's added, we don't need in the whole area of the triangle, we only need to take half of this. So we're going to use half of the base times the height in order for Jada to figure out what her area is going to be. 8 times 3 is 24, and half of 24 is equal to 12. So in this case with Diego, it's the whole shaded region, just base times height, but for Jada, she has to remember that she's only keeping half of it. So make sure you don't get confused there. Depending on how you find the area, you know what you're doing. Number 2, find the area of the triangle, explain or show your reasoning. Okay, so for this one here, maybe you wanted to extend it out and make a rectangle, which would have a base of 1, 2, 3, 4, 5, 6, and a height of 1, 2, 3, 4. So you have 6 times 4, which is 24. That's great, but again, we only want half of it. So we divide by 2, or we could think about it as multiplying by a half. It's the same idea. And that still is going to get you to what? 12. All right. For B, a couple things here. We could do some chopping, or I would prefer myself just to copy it up. 1, 2, 3, 4. So I'm going to come back 1, 2, 3, 4, and we'll connect the line there. I just prefer the parallelogram over the trapezoid. Just easier to draw and see. To find those, I don't have to worry about a midway point. I'm good. So in this case here, I have a base of 4. 1, 2, 3, 4. I have a height of, right there, 1, 2, 3, and I only want half of it. So 4 times 3 is 12, and half of 12 is going to be 6. All right, and that's how we did number 2. Moving to the next page, number 3. Number 3. Which of the 3 triangles has the greatest area? Show your reasoning. Okay, so let's do some comparison here. Let's go on this first one. Let's extend this out. Extend this out. So we have a base of 1, 2, 3, 4, 5. We have a height of 1, 2, 3, 4. And we only want to keep half of it. So 5 times 4 is 20. Times a half is going to be equal to 10. Okay? On this next one here, I can extend it if I wanted to. They might want you to chop it up in half. I'm not sure what they like you to do. I'm going to go ahead and extend it. I have 1, 2, 3, 4. So I'm going to extend this line up to 1, 2, 3, 4. And I'll extend to there to make that copy of that one. So I have a height of, or I have a base of 4. And my height would be this one right here, if I choose, which is 1, 2, 3, 4, 5. So again, I have 4 times the height of 5 times a half, because I only want half of it. 4 times 5 again is 20, times a half is still 10. All right, on this next one here, we are at a spot where I have 1, 2, 3, 4. So I'm going to extend this out to 1, 2, 3, 4. And go to there. So I have a base of 4. I have a height of 1, 2, 3, 4, 5. And I want half of that, which is going to be 10. Could I do it a different way? I'm sure that I could, right? I could go ahead and I could possibly cut this in half some way to make a trapezoid and do that whole thing. I just think that it's just, I'm seeing this a little bit easier than the trapezoid method, okay? If you see the trapezoid way, go for it. If you do trapezoid in the parallelogram, that's awesome. But I'm gonna do it that way, it just works for me a little better, okay? All right, and that's what we did there. So, which has the greatest area? They're all the same actually, so none has a greater area. Number 4. Draw an identical copy of each triangle, such as the two copies together form a parallelogram. If you get stuck, consider using tracing paper. Okay, so the way I've been doing it is I look and go, well, here's a base, 1, 2, 3, 4, and I'll pick a point on the vertice up here and go across 1, 2, 3, 4, so that I have these parallel lines. And then if I connect this one to that one, I now have a duplicate triangle and a parallel and a parallelogram. That makes sense? Okay, works great when they're on the grid lines. When they're not on the grid lines, it's not quite as nice, is it? Okay, so when you look at this next one, well, maybe that's not quite as nice to look at because it's a little bit curvy, not quite on the grid lines. It does line up on points on the grid lines, which is nice, but may not be as easy to see. So if we take this one here and rotate that around, so a long line matches a long line, we're going to end up with something like that. So I notice that there's a point right there. It's going to match. Kind of press down a little hard. Keep my pencil there to know about where it's going to be. Cool. And then I'm going to just connect the dots. So we have a line here, and we have a line here. Alright. So there's my copy, there's my parallelogram, something like that. Okay, and this next one here, we have a straight line on the vertical, which is nice, 1, 2, 3, 4. So I can take this vertice and go down 1, 2, 3, 4, and then play connect the dots like that, and I have the next parallelogram. So it's really convenient when they line up on the grid lines like this one does vertically and this one is horizontally. When it doesn't, it's a little more complicated, but it can be solved. 5. A parallelogram has a base of 3.5 and a height of 2. What's the area? Well, it's base times height, so it's going to be 3.5 times 2. So 5 times 2 is 10, 2 times 3 is 6, plus 1 is 7. You have 1 decimal, so we're 7, so 7.0, or just 7 units is our area, 7 square units. Parallelogram has a base of 3 and an area of 1.8. So we know that our base times our height is going to equal 1.8. So to find the height, we'll divide both sides by 3. So here's 1.8. 3 goes into 1.8, goes into 1 0 times, decimal point up on top. 3 goes into 18 6 times, with none remaining. So what's my height going to be? My height is going to be 0.6. That's my height right there. And one more. A parallelogram has an area of 20.4. If the height that corresponds to a base is 4, what is the base? So again, we have 4 times the base equals 20.4. So I'll divide both sides by 4. So the base is equal to 20.4 divided by 4. So here's 20.4 divided by 4. 4 goes into 2, nothing. 4 goes into 20 5 times, decimal point right up top right away. 5 times 4 is 20, so it becomes 0. We bring the 4 down, and 4 goes into 4 one time. 1 times 4 is 4, nothing left over. So we have 5.1. So our base has a value of 5.1. Alright, that's it for today. Have a great one, and we'll see you next time.